let's talk about Bayes' theorem. And look, I want you to forget about all the scary math for a second, because at its heart, this isn't really just a formula. It's a way of describing something all of us do every single day. We learn. I mean, think about it. You get tons of emails. How does your inbox just know that an email promising a free fortune is total junk, but an email from your cousin about a free puppy is the most important thing you'll see all day? It really does feel like a magic trick. But spoiler alert, it's not magic. It's actually this brilliant piece of logic, a kind of statistical engine that lets a machine get smarter over time. It teaches it how to weigh evidence and make predictions. So today, we're going to pull back that curtain and see exactly how it works. So here's our game plan. First, we're going to crack open that spam filter. Then we'll get our heads around the basic idea of thinking in probabilities. From there, we'll see the really cool part, how new evidence can totally change what we believe. And finally, we'll put it all together with the powerful prediction engine at the heart of it all. Ready? Let's dive in.
All right, first up, the smart spam filter. Let's start by unmasking this magic. How in the world does that little piece of software decide what's junk and what's actually important?
Well, the key thing to get here is that it's not just some giant checklist of bad words. No, it's a dynamic, living, breathing machine learning algorithm that is constantly adapting and getting smarter with every single email that hits your inbox.
It basically acts like a detective. It looks at all the clues, the words in the subject line, the body of the email, even who sent it, and it uses all that evidence to calculate the probability that the message is spam. Now, to understand how it does that, we need to talk about probability itself.
Which brings us right to our next section, thinking in probabilities. Before we can really get how the spam filter learns, we need to be on the same page about the fundamental concept that makes it all possible, the basics of chance.
Probability is really just a way of measuring uncertainty. We all get this. You roll a regular die, you've got a 1 in 6 shot of getting a 5. Simple enough. But things get really interesting when probabilities start to depend on each other.
This is something called conditional probability. It answers questions like, what's the chance of rain if the sky is already full of dark clouds? You see? That new piece of information, the condition of the cloudy sky, completely changes the odds. And that, right there, is the secret sauce. And that secret sauce leads us right into our next part, how evidence changes beliefs. This idea that one event changes the probability of another is the absolute core of Bayesian thinking. It's all about how new information, new evidence, forces us to update what we believe. Let's see how powerful this is with a real example. So, check this out. Imagine we have data on 105 job candidates. This table shows us two things: whether they took a specific training program and whether they ended up with a good salary package. Now, just looking at the totals, we can kind of see some patterns, but the real power comes when we start asking those what-if conditional questions. So let's ask a very specific question. If we know for a fact that a candidate did not do the training, what's the chance they got a good package? We're adding a condition, a new piece of evidence. Okay, let's compare these two. Without any extra info, the chance of any random candidate getting a good package is 35 out of the total 105. That's about 33%, a 1 in 3 shot. But the second we add that evidence that they didn't do the training, our whole focus shifts. We're not looking at 105 people anymore. We're just looking at the 60 people with no training. And out of those 60, only 5 got a good package. Whoa! The probability just plummeted to a little over 8%.
Do you see what just happened? That new piece of information dramatically changed our prediction. This whole process of updating a probability based on new evidence is the absolute essence of what we're talking about today.
So that brings us to our final section, the engine of prediction. Okay, this is all great, but how do we formalize it? How do we turn this intuitive idea into a reliable, repeatable engine for making predictions? Well, this is where we finally introduce the star of the show, Bayes' theorem. You can think of Bayes' theorem as the recipe. It's the mathematical tool that takes our initial belief, adds in the weight of new evidence, and gives us a new, updated, and smarter belief. It's basically made of 3 key parts. First, you've got the prior probability. This is just your starting point, your initial hunch. In our job example, it was that first 33% chance. It's what we believe before we know anything else. Next up is the likelihood. This part is all about measuring the strength of your new evidence. It asks a simple question: how compelling is this new clue?
In our case, the evidence of no training was very compelling. It pointed strongly away from our initial belief. And when you combine the prior belief with the likelihood of the new evidence, you get the posterior probability. This is it. This is your final updated belief. For us, that was that low 8% figure, our new, much more informed belief after we considered the evidence.
So you can see the whole process laid out. You start with an initial belief. You observe some new evidence. You evaluate how much that evidence should matter. And then you calculate a new, more informed belief. And here's the really cool part. That new belief, it can become the starting point, the prior, for the next piece of evidence you get. It's a constant loop. This is how learning happens. And this exact logic is what powers a really powerful machine learning algorithm called the naive Bayes classifier. Remember that spam filter? It uses this to constantly update its belief about whether an email is spam based on the evidence of the words inside it. And this isn't just for email. This same learning engine is used to categorize news articles, to help doctors with medical diagnoses by weighing symptoms as evidence, and even to help predict the weather. It's pretty much everywhere once you know what to look for. If you want to sum it all up in one sentence, it's basically this. Your new belief is just your old belief multiplied by how compelling the new evidence is. That's it. It's a formula for learning. So I'll leave you with this question. Now that you know the pattern, prior belief, new evidence, updated posterior belief, where do you see it happening in your own life? Whether it's deciding to bring an umbrella because the sky looks dark, or changing your opinion about a movie after reading a review, you're using Bayesian thinking all the time, probably without even realizing it.